Hi, everyone. Welcome back. Thank you to our moderators for supporting this live event. And thank you to our two guest speakers and global black belts, Daniel and Shruti, for being available to present today. So this is the last session of the series. I can't believe it's been 6 weeks since we started this journey together. We do have another cross-functional series planned out for the summer into fall timeframe, depending on my availability. So be sure to check out updates on LinkedIn and on GitHub. In the meantime, I am planning an Azure 100 level session for Microsoft Aspire hires or for folks new in their career or early in their career. So if this is of interest to you, do let us know. All right, so let's get started. So what you see on my screen is a hub and spoke architecture that we have been working with. The top half being the hub and spoke architecture in Azure, and then the bottom section are the privately connected branches. One is the site-to-site connected branch, and another one is an express route connected branch. Private endpoints and private link go hand in hand with DNS. So I covered a lot of this in my DNS session, but I'm going to do a quick recap of what we learned just to complete this discussion with DNS as well. So as you can see, from a placement perspective, we have an IaaS-based DNS server in the Hub VNet, which is a centralized model. This is a shared services VNet, and then of course in the spokes we have a VNet level DNS server, and then there is a DNS server on-prem. So I'm going to take a few minutes to go look at some of the DNS scenarios that we looked at in the previous session. So let's take a closer look at how DNS is set up in this hybrid DNS architecture. And here you will see that let me go through a few components. So here you see that we have a private DNS zone, and it has a record for storage in this case, and that is a private IP. And another important bits in this design are these VNet links that links this hub VNet to the private DNS zone. And then we have two places where the DNS is configured. One is at the VNet level, the DNS is configured, and then there is that default Azure DNS, the 168 IP that we looked at, right? So now that we have seen all of the bits, and then of course we have this on-prem sites as well. Let's quickly look at the DNS flows and how it works. So first we will look at how the resolution works within Azure, and then we will look at how it works from on-prem. So the pink flows are showing how DNS resolution for this private DNS zone will work from Azure. So of course it would first consult the VNet level DNS, which in turn will consult the Azure DNS, and by the virtue of these VNet links, you would get the private IP of the storage account. All right, so that's within Azure. And then let's look at the consideration from on-prem and how the flows will work. Again, on-prem cannot route to this 168.63 IP, the Azure DNS. So we still need a routing between this DNS server and this DNS that is hosted in Azure. And the green flows show how the DNS query would work. So first it would consult this local DNS. There is a conditional forwarder to the DNS that is hosted in Azure, and then another global forwarder, that the number 3 of the leg that goes to Azure DNS. And then finally, the fourth leg that links the VNet, and you get the private IP. All right, so that's the overall flow. And for to complete the full picture, if you were to resolve external sites in it, and we did the example of MIT.edu, for example, these orange boxes are showing recursive lookups. So in Azure, the Azure's DNS would do a recursive lookup and hunt down the IP for you. And for on-prem, you would have the local ISP's DNS, right? So this model, this full picture that you see over here is a very popular design. We call it the hybrid DNS design. Of course, it is using the IaaS components, right? This DNS server is IaaS based. So what we did was we also looked at an alternate design, which is very similar to this design, also centralized approach. However, it uses Azure's private DNS resolver. So from the flow perspective, it is identical to what we just looked at. So let's quickly look through the flows. And of course, this is on-prem to Azure resolution, and then this is Azure resolution. The blue flows are showing resolution within Azure. The main difference or the key component in this design is the forwarding rule sets. And be sure to check out the DNS video for a deeper dive on this as well. So for this session, we are going to use the IaaS-based DNS design. All right, so let's quickly recap. So this is the central DNS server. And if you want to look at the flows, you can always light up this optional DNS layer. It does get a little cluttered, so um, I've made it optional. All right. So with that, let's go to our first option. So before we get into private endpoints, let's look at the evolution of the private endpoint service, right? So this is a service called Service Endpoint. It's very similar to private endpoint. It was released before private endpoint, but the idea is the same. The idea is that you want to privately access these Azure PaaS services. So imagine that you have all of these PaaS services and you want to access them from this spoke in Azure without actually going over the internet. So that's the root, that's the use case for this. So let's see how we can do it. So there's a few things to see over here, and I'll go through each one of these individually. So when you enable a private service endpoint, it gets enabled at the subnet level. And then what happens is from this subnet, any traffic that's going to the PaaS services. So let's say we enabled the storage for private for service endpoints. Any traffic from this web subnet to storage would traverse the Azure backbone. And behind the scene, it uses the UDRs to override the system-defined routes. All right, so that's the green flow going from Azure subnet to a PaaS service. Now notice the on-prem flow. The on-prem user still uses the public IP and the public FQDN, right? So it still resolves. So the storage blob.core.windows.net still resolves to a public IP, and it goes over the public internet, but we use the firewall on the PaaS service to whitelist that IP. And then we deny everything else, right? So that's how it works with service endpoint. So what are some of the considerations with this design, right? So let's look at the considerations. So one of the biggest things you noticed is that it's still this traffic, the green flow from on-prem still goes over the public internet. So with service endpoints, you do not get a connectivity over the express route into the PaaS service, all right? And then the second consideration is imagine you had another storage account over here and it was something that you didn't didn't want this subnet to access. You don't get that level of granular control out of the box. Of course, to do that, you could enable service endpoint policy, but be sure to check out that policies are available for other PAD services. We continue to evolve there, but today it's available for storage account to make it more granular. And this is again to restrict data exfiltration to different storage accounts. All right, and then I just want to show you how, from a configuration standpoint, how that looks like in an Azure subnet. So if you go to the Azure subnet, the service endpoints, if it is enabled, it will show up over here. So in my case, I have it enabled for Microsoft Storage. And then this is the UDR that I mentioned that behind the scenes gets created and it overwrites the system route, and it goes over the Azure backbone. Notice no DNS required in this scenario because it uses the public FQDN. All right, so with that, let's go into the next option. So when you use this draw.io file, be sure to uncheck everything that's in the previous option so that the right things get lit up for the next option. So in this option, we introduce the private endpoint, private link, and private link service. So let's look at the terminology first. As you saw, as you probably noticed, I have these three icons listed over here, and those are three distinct services. So I want to make sure that we have understood the terminology here first. So before I go in the terminology, there is the consumer provider model that I want to highlight. So imagine that this is the PaaS service of interest that you want to provide the service for. So that's the provider side, and this whole side is the consumer of that service. Okay, so you will see this consumer provider throughout this session. It is kind of in the base layer, so you will see it throughout throughout all of the options. So let's look at the different terms over here. So going back to my icons over here, we will start first with private link. So private link right in the middle over here enables you to have secure access to any PaaS service. Okay, so that's the role of the private link. Now you have private endpoint, and notice the icon is slightly different. Private endpoint is a network interface that has an IP address, right, which gets projected in your VNet. Okay, so that's private endpoint. And then private link service is, imagine you have your own service, not an Azure PaaS service, but your own service, of course, still hosted in Azure that you want to bring to an Azure VNet, right? So we have a separate layer on that. In this one, I will cover private link and private endpoint. Private link service is in the next layer, all right? Now that we have all of the terminology, let's look at the flows. So there's quite a bit to see over here, and I will, it's color coded, so I'll go over it one by one. So when you enable private endpoint on a PaaS service, in this example, I have a storage account. Two things happen behind the scene. This this PaaS service gets projected into the Azure VNet, whichever subnet that you decide as the private endpoint subnet, and you get an IP in that subnet. And the second thing that happens is you have the option to automatically create a private DNS zone, which is also a recommended option. And that zone has an A record. Notice it has an A record for the storage account. All right, so that's how when you create the service, those things happen behind the scene. And now let's look at the flows. First, we will look at routing, and then we'll look at DNS. So from these orange flows are showing that now that it is in the VNet, we have routing from these paired VNets, right? So this VM and the spoke has routing to this .4 IP, so it would be 172.16.251.4. And then, of course, from an express route connected branch, you have routing. So let's look at the DNS. Um, Again, I could light up the DNS flows. It would get cluttered, but I'll just light it up for a few seconds just so you know how it would work behind the scene. And so these are all the flows which we looked at independently as well. But by the virtue of those flows, this VM, if you run a dig against or an NS lookup against the storage account, you get the private IP. On the paired VNet over here, you also get the private IP. But the most important thing over here is notice what happens to the external user. The external user would still get the public IP. And again, this is by the virtue of how public and private DNS zones work. It would still get the private IP. However, we would disable all public access to this PaaS service. And that is the key, right? So no public access to this PaaS service, and everything is accessed using private connectivity. And you see how DNS becomes very important. I have taken a few screen captures just to show you the consumer and provider flows. You can of course automate these flows, but I've put in a link over here to show those. And then let me just make sure I'm not missing anything. Yes, and there is another important concept of um, security. Remember how in the service endpoint, we were able to, with just one setting, we could expose all of the storage accounts. In this case, you have more granular control of that instance, and you only project the instance of interest into the VNet, and that gives a lot more security. Again, we continue to evolve this service. We do have we do have network policies for private endpoint that allow you to that give you more granular control with NSGs and UDRs as well. But again, DNS is a core piece. The reason being that this FQDN of the PaaS service has to be preserved just for the SNI header to stay intact. For most HTTPS services, that is required. All right, so with that, let's move on to the next layer, and that is the private link service. So let's see what the use case is for private link service, right? So similar to PaaS service that you saw on the right-hand side before, imagine that this is a service that is your own service, right? That you want to use in Azure. So private link service is a reference to your own service instead of a PaaS service. But it still works the same way. Notice the provider on this side, the consumer on this side. So essentially, this side will be your provider of your service, and this side would be your consumer of the service. So let's look at how the flows would work in this model. There's quite a bit to see in this, and I will go in the depth of IPs as well to understand this better. But for now, just understand that when you first thing you do is you create a private link service. Notice you in this diagram, you'll see all of the icons. So first you do is you create a private link service. That's the icon over here. Then you project that into the VNet, and that's the icon over here. You got an IP in your VNet. And then you have the private link in the middle, right? That traverses the Azure backbone. So when that happens, um, notice that now we have routing. So the pink flows are showing you routed paths, meaning an on-prem user can route to this IP, and then an appeared VNet, VM and appeared VNet can route to that IP as well. So how does DNS work in this? In case of a private link service, there is no private DNS zones, so you have to maintain your own DNS, right? So now let's take a closer look at what happens when you create a private link service. It requires you to give a NAT IP address, NAT subnet. And what is the use case for the NAT subnet? Let's take a closer look at how it looks. The use case is really that you can have overlapping IPs. Shruti is going to go into the details of that advanced use case, but what I would like to show you is how the traffic would look like from this red VM's perspective. So imagine that you are a user over here and you accessed this private endpoint. From this red VM's perspective, of course, by the virtue of this pink flow, you would get red VM's web servers output back. However, from this VM's perspective, this red VM's perspective, you're going to see the source IP as 172.16.200.5, which is the NATed IP on the NAT subnet, right? Now, what if you want to see the actual source IP of the VM that initiated the traffic? For seeing the actual source IP of the VM that initiated the traffic, we have a concept of TCP proxy v2. So if you enable that setting, what you can do is you can take a look at the packet capture to see the real IP. And a large shout out to Daniel for helping me decode this proxy protocol so that we can actually see the source IP of the packet that initiated the traffic. So it's very similar to the XFF headers that you may be familiar with. And then if you turn on the right Wireshark settings, you can actually glean into the proxy protocol and see the source IP. However, this is just for our own understanding. In the real world, whatever web server that you are using, Apache or Nginx, would be able to decode those proxy headers and do the right thing, right? Just wanted to show you how the headers were decoded. And of course, I've put some links over here. If you are presenting this, this is all kind of ready to go. This is the approval workflow. And just remember that this whole thing could be in a different VNet region and a subscription. All right. So with that, let's go into the next layer. Um, this next layer is often sort of misunderstood when it goes with private endpoint. So we this feature is called VNet integration. So let's see how this is different from private endpoint. There's a lot to see, again, color coded, so I will go each flow one at a time. So imagine that this is your web app and you want to access your Azure SQL database through the private backend IP. For you to do that, you have to enable something called VNet integration for this web app, and that essentially gives you access into the resources in the virtual network, right? So then you can access the private endpoint using this orange line. You can egress from Azure using this blue line. So this blue line is showing that you can use the NAT gateway to egress. The green line, of course, you can continue to access the web app using the public IP. Um, And let's look at how real quick, how the DNS resolution works. So I was in SSH'd into the container that hosts this web app. I did an NS lookup of SQL database.windows.net, and I got the private IP, and I did a curl on ifconfig.io, and I got the public IP of the NAT gateway. Of course, you can have Azure Firewall here as well, or any NVA, essentially the same services that you use in the VNet. Okay, and a quick screen capture showing what it would look like on the web subnet is that it would show up under subnet delegation. So it shows that that subnet is delegated to a web farm, web.server farms. Okay. And then let's go into our last layer. Last layer is a use case for Azure Front Door with private endpoint. Um, we covered this a little bit in our load balancing section as well, but the use case is that imagine you have a service over here, an Azure Kubernetes service, a completely private cluster, AKS private cluster, and that origin is not routable from the internet. So this red flow is showing cannot route to it from the internet. So what you do is you have this Azure Front Door Premium. Notice you need Premium, and you can enable private endpoints with Azure Front Door Premium. And then you can, by this, if you follow these pink flows, it creates a private endpoint in an Azure managed VNet. And then you can have this as a backend to Azure Front Door. All right. And of course, you can do the same thing. You could use the same concept for other PaaS services as well. If you don't want to make the origin routable or accessible from outside, you can attach it with Azure Front Door Premium. And then it will also work from a different subscription or a tenant as well. So with that, let me just make sure I'm not missing any points over here. Yep, so with that, it ends my part of the session. Thank you again for joining, everyone. It has been a pleasure to host you all, and I'll see you in the next series. Over to you, Daniel.